Good day, everyone. I am Linnea Marie Quisquino, and I will be discussing quality control in clinical laboratory, the basics. The objectives of this presentation is that you must be able to understand the importance of laboratory quality control and define important terms related to quality control in clinical laboratory. But first, let us define quality control. Quality control in a clinical laboratory plays an important role in detecting deficiencies and reducing errors in laboratory's analytical process prior to the release of patient's results. The purpose of quality control in a clinical laboratory is to ensure that the results being reported are accurate and precise. High-quality laboratory results involve commitment to all phases of testing system including pre-analytical, analytical, and post-analytical phases that will be discussed or is included in the next few slides. Sources of laboratory errors. There are a number of potential errors which can affect the quality of the clinical laboratory results. Pre-analytical phase includes those factors which affect the laboratory results prior to the handling of the sample in the clinical laboratory. Post-analytical factors are those which affect the results after the analytical phase is complete. These three phases can be targeted individually for improving quality, although it is well published that the most errors occur in the pre- and post-analytical phases. Pre-analytical phase. These are the errors which occur in the pre-analytical phase and create an impact on the patient sample before it is analyzed in the laboratory. There are a number of things which can go wrong from the time when the sample is collected from the patient till it is transported to the laboratory for analysis. These errors are as follows. Wrong patient information. The particulars such as the name, gender, age, ward, patient's posture, effect of exercise, dietary effects, medical history, pregnancy, effects of drugs and alcohol, etc. can affect the values of analytes. Improper collection of the blood sample. The result will be affected if the sample is collected in a bucket thinner other than the one which is recommended for the analysis of a particular analyte. For example, bucket thinner containing sodium citrate is used in the place of sodium chloride for analysis of plasma glucose. Inadequate quantity of the sample. An insufficient quantity of sample cannot be processed for all the analytes which has been requested by the clinician. Improper handling of the sample. Improper handling of the sample can lead to hemolysis of sample before it reaches the laboratory for analysis. Grossly hemolyzed sample should always be rejected as lysis of blood cells leads to release of certain intracellular chemicals and enzymes which lead to increase in levels of potassium, phosphate, and transaminases. The incorrect sample storage. If sample has not been properly stored or blood sample has been left overnight before being sent to the laboratory, it will become hemolyzed in 24 hours, especially at a warm temperature. There are other factors as well, such as heat and exposure to light, can change the actual value of many analytes and routine clinical chemistry such as protodegradation of bilirubin by light exposure. And as you may know that bilirubin is light sensitive. Okay, yeah. We are now in the analytical phase. The analytical phase begins from the time when the patient's specimen is prepared from the analysis to the time when the test result becomes available. Potential analytic errors, which may affect the quality of the result obtained, include sample measurements, sample pretreatment, reagent volume, measurement, sample of reagent, mixing, incubation, reaction timing, and calculation. These errors may arise in conjunction with the supplementary use of analytical equipment such as glassware pipettes, etc., which may not have been properly washed and calibrated. Another things to consider is the quality of the reagents and the ionized water used for construction of calibrators and control will also have the critical influence on the values generated. It is very important that the reagent should be prepared according to the instruction given by the manufacturer, and also the reagent should be properly stored when not in use. During analytical phase, the quality of the laboratory can be maintained by running internal quality control (IQC) daily and participating in the external quality assessment (EQA). In addition, specific rules need to be followed for accepting and rejecting the analytical run. The use of analytical method with high degree of accuracy and precision, as well as the proper maintenance of the equipment, also help in reducing analytical errors. Post-analytical phase mainly deals with the reporting of results after the completion of analytical phase in timely manner and in accepted format that can be understood and correctly interpreted by the healthcare professionals. The most common post-analytical errors include the reports being not legible and also the delay in delivering the reports to the clinicians or patients. As we have discussed, the three sources of errors in clinical laboratory, the that can be gained in the pre-analytical, analytical, and analytical phase. Now we will be turning on to the terms and definition used in the clinical laboratory. These terms are very important when it comes to the clinical laboratory. So now let us discuss them. Okay. First is accuracy. Accuracy refers to the degree of agreement between measured value and its true value rather. And it is generally measured by direct comparison to a reference value and a commonly used quality control serum with an accurate value assigned to it by the manufacturer. Next is precision, and it refers to the reproducibility or the agreement between replicate measurements. Precision is quantitatively expressed as standard deviation, or more precisely as coefficient of variation of the results in set of replicate measurements. Hence, good precision means least coefficient of variation. And ideally, laboratories should be striving for both accuracy and precision. Um, Now, this specificity describes the ability of a method to measure solely the component of interest. A lack of specificity could lead to falsely elevated result where the test is measuring components other than the analyte of interest. Sensitivity. And sensitivity is the ability to detect small quantities of measured components, and it will be subsequently affect both precision and accuracy when attempting to measure levels at the bottom end of the clinical range. Lastly, please to take note about repeatability, and it is the degree of agreement within successive measurements which has been done on the same sample under same condition within in a very short time. And as we all know, the experiment don't just take a single run, but it undergoes multiple trials to test if the result is or are reliable. We're now on the last slide, and, and it's just the additional information that will not be further discussed as my range of as it doesn't reach my range of expertise yet. So without further ado, let me introduce some more information. Okay. The interpretation of the quality control data is done with the help of both graphical and statistical tools, and as I said, will not be discussed. Quality control data is most commonly visualized with the help of quality control chart, charts, which include Levy-Jennings chart and Westcard rules. Both are useful in detecting trends in shifts observed from the average target value. Corrective and preventive action (CAPA) is an important path towards the improvement and effectiveness of quality management system in a laboratory. The root cause of analysis of any problem or deviation can be easily done by implementing CAPA laboratory. And that's it. That would be all. Thank you.